Okay, let's go ahead and get started here. My name is Henry Throop. I'm an astronomer at NASA in Washington, D.C. Thanks to my wife, Heidi Huttenbach, who's a Foreign Service officer, who's set this up this morning. We've traveled around the world with the State Department, living in Mexico City, in Washington, D.C., in Pretoria, South Africa, in Mumbai, India, and now we're back to Washington, D.C. So I'm going to take about 45 minutes to talk about a fantastic journey that we've been taking, not around the world, but out to Pluto, at the outer edge of our solar system. So thank you for coming here. What we're going to do is I'm going to talk about Pluto, and then through the chat window, I'll open it up for questions at the end. You can type your questions, or your parents can type their questions into the chat window at the end. That's going to be easier than using the microphone to try to listen to everybody online with their questions. So first thing one of the most questions I get asked a lot when I say that I'm an astronomer is people asking me how often I go up into space. Here's the answer: I've never been up into space, so I'm sorry to disappoint you, but I'm an astronomer, I'm not an astronaut. Astronauts are the people who wear the spacesuits and go up into space. I'm an astronomer, and I wear a normal suit, and I go to an office or use telescopes to study the world around us. I use telescopes and I use spacecraft. We spend a lot of time using computers. We spend a lot of time programming and analyzing data and writing papers and talking with our colleagues and so forth. And so I use these to explore the solar system and the universe around us to see where the solar system came from and how everything works in our solar system. I get to use telescopes around the world. This is a telescope in South Africa that I used. People ask me, what do I need to do to become an astronomer? And here's what you can do. Here's what I did. I grew up in Oregon. I went to high school there. I took a lot of physics because physics was really fun. And I did science fairs and things like that. I was in a science club in high school. And then I studied physics when I went to college. I went to a place called Grinnell College, and I studied physics there. And then I went to grad school, and I learned more about astronomy there. I went to grad school for 5 more years. If you add up 4 years and 5 years, that's 9 years of college, which seems like an awful lot, but it was actually really, really fun because you get to be an astronomer and use telescopes and explore the world while you're doing that. And then we've been able to move around the world and live in India, South Africa, and Mexico while doing this and while teaching astronomy and while doing astronomy around the world. So it's been really exciting. If any of you are interested in doing science and doing astronomy and physics and chemistry and biology and math and the other sciences, I encourage you to do so if that's something that's really fun for you. There's lots of people who have jobs doing this, and it's really, really cool. So if you have questions about that, we can talk about that afterwards. So we're going to talk about going out to Pluto with our spacecraft. Here's a picture of a galaxy, because I want to talk about where our sun and where our solar system fit into the whole universe. This is a galaxy. This galaxy has 100 billion stars in it. That's a 1 with 11 zeros after it, which is a really, really big number. Our galaxy is called the Milky Way galaxy, and all the stars that you can see when you go outside at night are inside that galaxy. That little red circle there, that's where our sun is. Now, this isn't a picture of our galaxy. This is someone else's galaxy because we're inside our galaxy. We can't really take a picture of our galaxy. But if you could, that's where it would be. There's 100 billion stars in our galaxy and 100 billion galaxies in the universe. And if you put that together, that's a 1 with 22 zeros after it. It goes like 22 zeros. It's one of the biggest numbers that you can think of in the world. So here's a picture of our solar system that we're going to draw. It's called the solar system because the sun is at the center of it. The sun is solar. And so we have the sun at the center, and then we have Mercury, Venus, Earth, and Mars, the small planets as we're going out from it. They're mostly made of rock, so you could stand on them. Rock and oceans on the Earth also, but rock below the oceans. So we have Mercury, Venus, Earth, and Mars. We call those the rocky planets. And then we have Jupiter. Jupiter is the first planet which is made out of gas. And so it has a lot of hydrogen gas, and gravity keeps it together. It's like a big cloud, but it's a really, really big cloud. So it's thousands of times bigger than the Earth. The Earth could fit in one of those tiny spots on Jupiter. It has a great red spot on it also. Then you have Saturn. Saturn has its tilted rings like that. If anybody's seen Saturn through a telescope, you know that through a telescope, it looks just like that photo there. It's really, really cool. Saturn is a great thing to look through in a telescope. Then we have Uranus, and then finally we have Neptune beyond Pluto, or beyond Uranus. And so these are the 4 gas giant planets. They're all mostly made of hydrogen and made of helium, and they're really big clouds, but gravity still keeps them together. And all these 4 planets are bigger than the other ones inside. But that's not the edge of the solar system. What do we have beyond that? It's Pluto, our friend Pluto, which is my favorite planet. Now, as you get further and further in the solar system, things get colder and colder as you're getting further out. And that's because it's just like a fire. You know, as you get, if you're really close to a fire, then it's really hot. And that's what happens with the inner planets, because they're really close to the sun. Mercury, Venus, Earth. Okay, they get all their energy from the sun, and you're really close to it. But as you get further and further out, you get like medium cold as you get out to Jupiter and Saturn, and then you get super duper cold as you get out to Pluto. So the further away you are from the sun, the colder it gets in the solar system. Now, Pluto isn't the complete edge of the solar system. In fact, there's a lot of stuff out beyond Pluto. It's just so far away that we don't know very much about it. And so it's hard to study it. But what we do know is there's thousands of things which are just like Pluto, very similar to Pluto, out beyond Pluto. And here's a map of some of them. And we call these the Kuiper belt. And you can think of these as like, you have the planets made of rock, you have the planets made of gas, and you have the planets made of ice. Because everything out at Pluto is going to be icy because it's so cold out there. It's hundreds of degrees below zero. People have been looking at the planets for a long time. So this is where we used to live in Bombay, in India. And here's a picture of some of the planets in the sky in the morning. And you can see the sun, it's just starting to come up. You can see the moon, Venus, Mercury, Earth, of course, Mars, Jupiter. We're also up in the sky, all in one night. And people have been looking at these planets for a long time. Now, they haven't, Uranus, Neptune, and Pluto are too small that you can't see them with your naked eye. But all the other planets, you can just go outside and you can see them, even if you're in a really bright city, even if it's not perfect conditions. You don't have to go to a dark sky to be able to see lots of planets up in the sky. So I'm going to tell you a little bit about how we discovered Pluto in the first place. So in 1874, 150 years ago, there was an astronomer from France named Leverrier, and he was looking at the position of Uranus in the sky, and he was like, Uranus isn't exactly where I think it should be. I think it's being pulled around by the gravity of something else. And he looked around, and he predicted, I think there should be another planet up here, and it should be right here in the sky. And then he looked up there with a telescope, and he found a brand new planet. It was pretty amazing. That was the first time anybody had found a new planet ever. One of the most amazing things. I've never found a new planet. Most people have never found a new planet. But this guy, 150 years ago, he found a new planet because it was Neptune. And he predicted where it would be, and then he found it with a telescope. In 40 years later, Percival Lowell was looking at he was an astronomer from Arizona, and he was looking at the position of Neptune. And he was like, Neptune looks like it's being pulled around a little bit. I think there's another planet, and it should be over here. And he pointed his telescope over there, and what did he find? Nothing at all, because his calculations were wrong. But he used this big telescope, and he looked, and he looked, and he looked, and he didn't find anything. And then he died, and he still hadn't found anything when he died. But there was someone else who he hired before he died, which is Clyde Tombaugh. And this guy came out, he took the train up, and he used a telescope, he used this telescope here, and he used a little trick to look for planets in the sky, to look for a new planet. And what he did is he took a picture of the sky one night, and then he took a picture of the sky the next night. And so he looked for things that moved. And he didn't look for the constellations that moved, because we know the constellations, they keep their shape from one night to the next night. But he was looking for anything that did move against the constellations. And so here's one of the pictures he took right there. You can see a lot of stars there. And I'm going to circle, and then the next week, he took this next picture. So he went back and forth and back and forth. And if you look carefully, there's one star in there which is moving. And it's moving because it's not really a star. It's moving because it's Pluto. Let me show you where it is. I'll show you where it is. I'm going to circle it. Right there. And a week later, it moved to right over here. So there it is a week later. And so this is one of the most, this is the discovery image of Pluto, and it's taken by Percival Lowell in 1930. When we first found Pluto, nobody knew really anything about it. Like, all they knew about Pluto is it's really faint, and it's moving really slow because it's a long way away. That means it's a long way out in the solar system. In fact, it took 250 years for it to go around the sun, and it hasn't even been 250 years since it's been discovered. So it's only gone even less than once around the sun so far since we've known about Pluto. It's that far away. So we knew that it was tiny and it was a long way away, and that's all that we could see about it. Like even with the biggest telescope, you couldn't see anything on Pluto. Here's a picture that we took in the 1970s of Pluto, and you can see that's kind of fuzzy, kind of looks like a blob there. And then on the left is one photo, and then the next on the right is a photo taken a couple of days later. And you can see the blob kind of changes. There's kind of a blob on top on the left there, and that blob goes away on the right. And that's because Pluto is actually rotating, and it has a moon going around it. And what you're seeing is this moon going around it. This is the first picture of Pluto's moon. It's kind of hard to see in this picture because this picture is really fuzzy, but that's the best telescope that we had at the time. So we found this moon called Charon. And now that we have the Hubble Space Telescope, we can take a better picture. And here's Pluto and Charon right there. So on the left, you see Pluto, and on the right, you see Charon. Now, this is the best picture that we can take with the Hubble Space Telescope. And you can see that Pluto and Charon, there's still kind of blobs there. You can't see any craters on the surface. This doesn't look anything like a picture that you would see of the moon, where you have lots of craters and volcanoes and ditches and things like that on it, because the resolution is, because Pluto's so far away, it's just hard to see anything. So we've used Hubble Space Telescope to find a couple of new moons. We now know there's even more moons going around Pluto. We found one called Nix and one called Hydra, and then we found one called Kerberos, and then I was part of the group that found one called Styx. And Styx is circled there in black, and it's really, really hard to see, but I guarantee you that it is actually there. So Pluto has 1, 2, 3, 4, 5 moons going around it. So this is just like our moon going around it. Our moon goes around once a month. Pluto's moons go around it, and they see them in the sky there. So this is everything that we would know about Pluto. And we don't know very much. We know about, this is before we went there with our spacecraft. We know that it's kind of small and has all these moons going around it. And we see a little bit of atmosphere on it, but that's all we know about it. Now, if you want to take some great pictures of Pluto, how do we do that? Because with the Hubble Space Telescope is an amazing telescope, but it's only about 2 meters across. So the size of the mirror in it is about the size of one of your parents, maybe about 2 meters high. And you could build a bigger and bigger telescope like this. Whoop! There's a big telescope. You could build a bigger and bigger telescope, but it's really, really hard to build a big telescope. So here's a trick you can do. You can build a small telescope and fly that small telescope all the way to Pluto. Whoop, 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 whoop. There it goes. We're flying our small telescope to Pluto. And that's actually what NASA does. NASA builds small telescopes and flies them through the solar system to go visit planets. And we can go visit Mars with a small telescope. We can go visit Pluto with a small telescope. We can go visit Jupiter or Saturn with a small telescope, and we can do that anywhere in the solar system. Now, we can't visit other stars. We can't visit other galaxies because those are much longer away. But we can visit things in our solar system, and that means the planets. We can visit the planets. And here's our spacecraft that we built to do this. So this is a spacecraft. It's called New Horizons. That's its name. It was built by NASA and built by a group that I work with. It's about the size of a piano. So it's smaller than a car, but bigger than a lawnmower. There's no people on this. So people ask like, oh, how's it going to land on Pluto? How are the people going to get back? We didn't send any people on it. We didn't send any astronauts on it. This is a robot. And it turns out if you're going to send something through space and it's going to take 9.5 years to get there, it's much better to send a robot than send people, because people need food and bathrooms and air and a bed and all that stuff. So you don't want to send a person in this thing. You want to send a robot, because all a robot needs is electricity, and that's it. So this is this actual spacecraft. It was launched in 2006, and it flew 6 billion kilometers to get to Pluto, and it arrived there in July of 2015, so 4 years ago. And here's a picture of the spacecraft. And so you have a couple of different things on it. You have a battery, and you have a camera, and you have a radio. And this is, if you think about it, you've seen something which also has a battery and a radio and a camera on it. Some of you might even be using it right now, like a cell phone. So here we have a nice iPhone 11, and it's got a camera, well, 3 cameras, just like we have 3 cameras also, and it's got a battery and it's got a radio. And so really what we're doing is we're taking a little cell phone and we're sending it up to Pluto. Now, our spacecraft is a little bit bigger than this, and that's because it has a bigger battery, it has a bigger camera, it's a bigger radio, it has some other components on it too, but it's the same basic idea. We click a picture, we hit send, and then we send it back to the Earth where we can see all the pictures. Here's a diagram of our spacecraft close up. You can see all the different cameras on the side of it. We have 3 different cameras on it that measure in different frequencies of light. So one measures what we call the infrared, and that tells us about what the surface is made of. And one measures what's called the ultraviolet, and that measures what the atmosphere is made of, the atoms and the molecules. And then we have one that takes pictures just like a regular digital camera on your phone or on your iPad. And then up top, that thing that looks like a satellite dish, that's how we talk with it. We send radio signals back to the Earth and from the Earth. And then the black thing on the right, that's the big battery. This battery, you might think that you have a good battery on your phone or on your computer. Well, this battery lasts for 88 years. So it's going to give us power for a long time. It's going to be great. So that lets us fly a long way through the solar system. Here's a little timeline. And this shows us when we were chosen by NASA. It took us 4 years to build the mission because NASA told us to start in 2001, and then it took us 4 years to build the mission, and then we launched in 2006. Here's some pictures of constructing our mission. So we were constructing it outside of Washington, D.C. There's a lab that we use called the Applied Physics Lab. And here we are, we're building it out of aluminum. That's the same thing like that aluminum can is made out of, but this is stronger, thicker aluminum so that it will last for a long time through space. Here's people assembling one of the cameras for it, and this person is wearing a bunny costume. So why are they wearing that? And they're wearing a face mask, and they're wearing gloves. That's not because of coronavirus. They were a healthy person. They were just putting it on there because, well, this thing is designed to detect what Pluto is made of, and if they put on fingerprints and hair. And if they get into the optics, then maybe we'll go up to Pluto and we'll be like, what's Pluto made of? We'll take a picture and we'll see fingerprints and hair. And we'll be like, oh, Pluto's made of fingerprints and hair. But that's not right. So what we want to do is protect it and keep everything clean when we're building the spacecraft. So that's what we were doing. Here's people assembling the spacecraft, putting the wires onto it, and assembling the main antenna on top. I like this photo. This looks like doctors with their baby. And here we are making the spacecraft spin. We kind of have to put it on we have to spin it up to make sure that it's balanced properly because it's spinning when it's in space. And so we want to make sure that it spins safely and uniformly, that it's balanced, it doesn't wobble when it's spinning. It takes so many people to build this spacecraft and fly it and go out to Pluto. So here's about 100 of us. This is part of the team. And at the center, in the black shirt there, the guy who's running it, his name is Alan, and I'm way in the back there in blue. And then there's lots of other scientists, but not everybody on the mission is a scientist. Some people are engineers who actually built it. Some people are people who designed the optics, who designed the telescopes on here. Some people are writers. Some people are teachers. Some people are professors. Some people are computer programmers. Some people are journalists. Some people are people who meet with the public and talk with the public and explain the science that we do. So it takes so many different people to run these missions. And it takes a lot of scientists, but it takes a lot of other people as well. So there's places for so many different people to work on these missions. So when I started working with this mission, I was in Colorado. So we built parts of the spacecraft in Colorado. We flew them down to Texas, and then we drove the spacecraft from Texas over toward Washington, D.C., and then from Washington, D.C. out to Florida. And Florida is where Cape Canaveral is and the Kennedy Space Center, and that's where we launched it from. So here's a picture of our spacecraft after we built it, and this looks like a rocket. The spacecraft is actually inside the rocket. That's the nose cone on the left there. And the spacecraft is inside the rocket, inside the nose cone there. And the rest of the rocket there is just a flying fuel tank, basically. It's all full of fuel. In fact, it's hundreds of thousands of kilograms, 600,000 kilograms. That's 1 million pounds of fuel. And one thing that you might know about fuel is it takes To have a fire is what a rocket is basically. And to have fire, what do you need? You need fuel and you need oxygen. How much oxygen is there in space? Not very much, in fact, zero. So if you want to have a fire in space, if you want to put a rocket up there, you need to bring along your own oxygen. So that's what we did here. We're taking kerosene, which is basically the same as gasoline, and we're taking our own oxygen. So this fuel tank is filled halfway with oxygen, liquid oxygen, and then halfway with kerosene for the gas. And we don't burn this thing, we don't burn this engine for the whole time that we're going to Pluto. We actually only burn it for less than an hour. And then it's cruising. It's just like throwing a bowling ball or throwing a paper airplane. You know, if you push a paper airplane, it starts going and then it can cruise for a long way. Or if you push a bowling ball, it can go down the lane for a long way if you steer it in the right direction. So what we do is we line up properly, and then we turn the rocket on and we steer it so that it goes in the right direction. And then it all burns out, but then it cruises and glides all the way the rest down to Pluto. So here we are here we're at the as we're rolling out the launch vehicle in the morning, rolling out the rocket. Here we are as we're assembled at Cape Canaveral in Florida to watch the launch. You can see there's a big building on the right. That's where they built the space shuttle and the Saturn V rocket that went to the moon. And our rocket is on the left there, or the center, about 5 miles away from us. And we wanted to be a long way away from it just so it was safe. There's also a lot of alligators there, so we had to be up on this bridge to stay out of the danger of the alligators who would eat us like a hamburger. Lots of people with their cameras watching this spacecraft go off, and here we go. So this is really exciting. Woo! I'll show you a movie of this too. Really exciting to see this spacecraft go up into space. Here's you can see as it's coming from the ground and the trail of the rocket as it's going through the clouds. This is one of the geologists on the mission. This is one of the artists on the mission. And here's a movie of the mission, of the launch.
T-minus 1 minute and counting.
T-minus 1 minute and counting.
Minus 55 seconds.
Minus 55
Third
seconds.
Stage is go.
Roger.
So they're going through all the checks on the rocket. That's a big lightning tower there because this is full of fuel. What would happen if this
T-minus 45
rocket was hit
seconds.
by a lightning bolt overnight before it launched? The whole
Minus
thing
40
would explode.
seconds.
So you want to get rid of lightning.
Stable at step 3.
You can see some smoke coming off. That's just the liquid oxygen, which is really cold and gives what looks like smoke
29
coming
seconds.
off.
Dow's locked. ECS reduced for launch.
Roger. Minus 25 seconds.
Status
25
check.
seconds to launch.
Go Atlas. Go Centaur.
T-minus 18.
So the closest people are about 2 miles
15
away
seconds.
as they're watching this. And we're about 5 miles away.
11, 10, 9, 8,
8,
7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system.
This is so exciting to see the launch go off.
T plus 35
engines,
seconds.
They're all burning right there.
T plus 40 seconds.
And we can only see it for about a minute before it goes beyond the clouds. Now, fortunately, NASA has some airplanes that were chasing it. Some really fast airplanes like F-15s. They can't keep up with it for a long time, but they can follow it for a little bit and get some video of the rocket going toward space.
1 minute
up
into flight.
space, but they can follow it as it's going at least away from Florida. We have a bunch of telescopes following it from the ground as well. So in a little bit, believe it or not, some of our engines are almost finished burning. They've used all of their fuel. And so in just a couple seconds here, some of the engines are going to stop burning and they're going to toss off because they're just an empty fuel tank. We don't want to carry an empty fuel tank all the way to Pluto. That would just be a lot of extra weight and that would slow us down. So these engines are going to pop off.
And we have Boda, RD-180s throttling up to 100% thrust.
These engines were actually made in Russia. So it takes collaboration between a lot of
T
different
plus
countries
1 minute 45 seconds.
to make these
Everything
rockets.
continues to look
solids
good.
1 and 2.
Boosters
3
have
and
just
4,
jettisoned.
5. Solid separation looks good.
It looks like it just exploded there, but nope. Those are all
Main
falling
stage
back
still
into the
running
ocean.
fine.
Those engines have burned out, and we're going to go.
T plus
Vehicle
2 minutes
stern's
and
been able to
counting.
right on time.
2
Vehicle
minutes.
attitude rates look good.
Start ground system securing.
And now it's about 30 kilometers
Vehicle's currently
down from
flying
where
at
it started.
33 nautical miles.
And it's going to burn its main engine for about another 40 minutes. And then it's going to do one final burn and be on its way to Pluto. And just like a bowling ball, you just push it there. And then the rest of the cruise for 9.5 years is just an unpowered cruise where it just glides through space to get to Pluto. And we were going really fast. If you have the fastest car that you can get, maybe you get a Ferrari, you could drive to the moon. It would take you about a year to drive to the moon. It's about 250,000 miles to get to the moon. If you're going in Apollo 11, how long did it take the Apollo astronauts to get to the moon? Well, it took them about 4 days to get to the moon. But us, New Horizons, we were the fastest spacecraft that we've ever launched from the Earth. It took us only 9 hours to get to the moon. It took us a tenth as long as it took the Apollo 11 astronauts to get to the moon. Now, we didn't go to the moon. We didn't land there. We just went to the moon's distance. And the reason why we were so much faster is because we're so much smaller. And so we had a really, really big engine, and we had a really, really small spacecraft. And so that's because we didn't have people, and we didn't have a dune buggy, and we didn't have air, and we didn't have toilets and beds and things like that. So it's much faster to send a robot out through the solar system than it is to send people through the solar system. That's why we could go 10 times as fast as the Apollo astronauts. So we launched in 2006. That's what that movie is from. And then it took us a long time to get to Pluto, because Pluto's a long way away. It's 6 billion kilometers away. So we went 2007, 2008, 9, 10. Some of you are probably being born right now. 2011, some more of you are being born. 2012, 13, 14, 15. Finally, in 2015, we were getting close to Pluto. And here's a little map of where we went. So we left the Earth in 2006, then we went past Jupiter, and then we went past the orbits of Saturn and Uranus and Neptune, and finally we intercepted with Pluto there. Pluto's the one in the yellow in 2015, 5 years ago. I'm just going to show a couple of pictures of what we saw at Jupiter, because it's really cool. It took us a year to get to Jupiter. This is the best picture of Jupiter that we've ever seen. Best picture of Jupiter, and you can see Jupiter's red spot there, and you can see the bands and the clouds in Jupiter's atmosphere. Jupiter's really an awesome planet, really huge. The Earth would fit in one of those tiny dots there. Even inside the red spot, there'd be like 100 Earths that would fit inside the red spot. Here's one of the rings of Jupiter. Jupiter's really cool that it has rings, and it has moons going around inside these rings. This is one of the moons of Jupiter, and this is a moon that's all covered with volcanoes. In fact, you can even see a volcano which is going off right there. Right on the top, there's a plume of smoke and ash and dust which is coming out, and then gravity is causing it to fall back on the surface of Io. And this is a volcano. This moon called Io is the place in the solar system where there's more volcanoes than anywhere else in the whole solar system. Io is covered with volcanoes, and every time we take a picture there or if we go there, we see there's new volcanoes. It's just as if there's new continents coming out on Earth all the time. So it took 9 years for us to get to Pluto. What were we doing during that time? Were we just like taking a nap, like we were not sleeping. We were being super busy. And the reason why we were being super busy is that we just had one chance to get to do Pluto right, because we were going past Pluto really fast. I told you that we weren't landing there, and we weren't taking samples and bringing them back. We were just flying past Pluto. And so this is just as if you're driving to the mall, or let's say you're driving to Yellowstone, and you see something out the window, and you take photos out the window, and then you keep on going. You don't get to stop there. Why don't we stop on Pluto? That seems crazy. It's because we're going too fast. And in order to stop, we'd have to slow down. To slow down, we'd have to take lots of fuel along with us to slow down. And all that fuel is really heavy, and we didn't have space for it. So we spent all this 9 years basically practicing, making sure that our encounter was right, making sure that the spacecraft was programmed right, and so forth, so we could have a great time at Pluto and take the best pictures that we could and understand what was going on at Pluto. So it's kind of interesting that we, when we first launched we were going to go just to Pluto. We were going to explore Pluto and its moon called Charon. And then we found some more moons, Nix and Hydra, and then Kerberos, and then Styx. And so it turned out that we have all this new, Pluto's a really cooler system than we thought it was when we first launched. It keeps changing, or it doesn't keep changing, but our knowledge of it kept getting bigger and bigger. And, but there's 5 moons go around Pluto, and we want to be really careful that we didn't have a problem with one of those. Now, we weren't going to crash into a moon. But everywhere there's moons in the solar system, it turns out there's often a lot of dust in the solar system as well. And we thought that it might be possible that all these moons could make a lot of dust, and then there would be a lot of dust near Pluto. And a spacecraft which is going really fast, our spacecraft is going 30,000 kilometers every hour, 20,000 miles per hour. And normally if you're driving in your car and you hit a piece of dust, like, it's gonna just land in your windshield and then your car will be fine. But if you're a spacecraft and you're going 20,000 miles per hour and you hit a piece of dust, it can actually put a hole in your spacecraft and it can blow up the spacecraft, send it out of control. And so that's not what we wanted to do. A dust particle just the size of a millimeter, size of a period, going to end this mission. So we wanted to make sure there was no dust in the Pluto system. So we used lots of telescopes, we used lots of computers to model and see if there was dust there. And we didn't really know, but we were concerned about dust because wherever there's moons, there might be dust. And if there's dust, it means it could mean the end of our spacecraft. We did a lot of work. We figured it out in the end, like, it's going to be safe. So we can actually fly to Pluto, which is good because we were going to fly to Pluto and we wanted to know how to do it safely, and we could get really close to Pluto and take the best pictures. So it worked out well. So we weren't taking pictures of Pluto the whole time because Hubble has a really big mirror, but our Pluto spacecraft, I told you, has a really small mirror. So we didn't actually turn on the spacecraft for quite a while. It only makes sense to turn on our spacecraft and start looking at Pluto when we're close to it. But now, by 2015, we'd been flying for 8 years, and it was almost time to turn on our spacecraft so we could start looking at Pluto. And here's the first picture that we took of Pluto. And you can see Pluto there, the blob at the top, and Charon is its moon, the blob at the bottom. But they still look just like blobs, but they look about like that image from Hubble. And now, every day, as we get closer and closer, we're going to see better and better pictures. So here's a picture, and you can see it getting closer and closer. And here's a picture. Here's a movie where you can see Pluto and Charon going around each other. And so we're getting closer and closer every day. And here, now this is a picture we're still getting closer, and we're seeing it getting bigger and bigger and bigger. And we're seeing more surface detail, more features on the surface, more craters and mountains every day. Now you can't quite see exactly what's going on there yet, but every day we got more pictures. Until, on July 4th, we were waiting for pictures to come down, and suddenly the spacecraft vanished. We were listening to it with our antennas. We have some huge radio antennas that we listen to it with, and the spacecraft vanished. And we were like, where did our spacecraft go? And so we talked with the antennas, and we thought, well, maybe if there's a storm, maybe that can sometimes get in the way of the radio signals and block it. And sometimes if there's a problem with maybe the motors in the antenna are broken, or they have a power failure, and that can cause a problem. So we thought, maybe that happened. But we looked at all that, and nothing. We couldn't find our spacecraft. It was just lost. And this is about a week before we were actually supposed to get to Pluto. So we weren't quite at Pluto yet, but we were almost there. We had a week to go. And we searched around and we couldn't find it. We looked all over the sky in that region. And finally, about 2 hours later, we found our spacecraft. And it was waking up, and it told us to send a message to us and said, help me, I'm confused. I just turned off and I don't know why. And so this is kind of like what might happen, if you're lost with a friend, and you start texting with your friend back and forth, and you're like, hey, where are you? Are you okay? And you send some messages back and forth, and then your friend says they're okay, and you're sending a message back and forth with them. And but every time we send a message to our spacecraft, it takes 4 hours to get all the way out to Pluto, and it takes 4 hours for the message to get back to us, and so it takes 8 hours every time we try to send it a message. And and Pluto is so far away that we didn't want to do that too many times. Otherwise, it would take all of our time. We only have a week until we're supposed to get to Pluto. So we sent messages a couple of times, and we figured out what the problem was. And we figured out that we had actually programmed we'd asked the computer to do something too much. and we'd overloaded the computer on it because it's a pretty old, simple computer. We'd overloaded the computer, and then it had shut down and rebooted. And so luckily, we have a great woman who's running our operations. Her job is to keep the spacecraft safe and make sure that the spacecraft is healthy and keeps responding to us and talking with us. And her name is Alice, and she's what we call our mission operations manager, which we abbreviate as being our mom. And so she's the one responsible for it. And she and her team figured out what was happening with the spacecraft, and they woke it up, and they reprogrammed it, and they turned it back on. And then 2 days later, we were back on track to go past Pluto. And if it wasn't for her saving our spacecraft, then we might not have been able to go to Pluto at all. Or we might have gone past Pluto and not taken any pictures because it would have been turned off. So here's our pictures of Pluto. They started coming in again. And our closest flyby is about a week away here on July 14th. Images are getting better and bigger and bigger. And so here we are. This is the morning of the flyby. And all of us, we have about 200 scientists and engineers. We're all staying at one hotel in Maryland. There's the TV crews watching us as we're coming out of the hotel in the morning. It's about 5 o'clock in the morning, and we're going over to the lab for the final day where we're going to go past Pluto. Here we are in the lab. This is 6 o'clock in the morning, so we got up early. Those are all the scientists and engineers, and we're waiting for this first image to come down from Pluto. You want to see the image? Let's see it. This is the first picture of all of Pluto at high resolution. Woo! All right, so this is what we've been waiting years and years and years to see. This was amazing. This is a true color image, which means it's the same color as if you were to go out there and look at Pluto yourself. You would see it, and it would look just like this. And we didn't have any idea what it would look like. But you can see that it has some areas that are really dark on the bottom there. It has some areas that are really have some texture on it, and some areas that are really smooth. And then you can also see that Pluto has a heart on it because we love Pluto and Pluto loves us too. Now, if you compare Pluto with the moon, here's one really simple thing you can do. There's a picture of the moon on the left, and the moon has all these craters on it. And a crater in the solar system is caused when something slams into, when something hits something else, like an asteroid or a comet or a meteor comes down and it makes a big hole. And we see this all over the moon. And even there's some places on Earth where we've had craters and asteroids and comets that have hit the Earth and made a big crater like that. But on Pluto, on the moon, it's all covered with craters. There's craters everywhere you walk. You're standing in a crater. But on Pluto, you can see a couple of craters there. Like on this picture, there's one crater there, but there's not very many craters. So Pluto looks like, for some reason, it hasn't been hit by very many craters, or there's something that's erasing all these craters as they're there. And we actually think that what's happening is all these craters are getting erased. There's something on Pluto which is kind of repainting the surface, putting a brand new surface on Pluto. Pluto's really old. We think that Pluto and the moon were all made at the same time. They're made billions of years ago. But we think that something on Pluto, the surface is really young because it's getting resurfaced. Maybe Pluto's melting, maybe there's something being deposited on Pluto so that it has a new surface, even though it's a really, really old planet. So this is all our team, and just this first image came down. You can see all the scientists and engineers here being really excited to see this first image come down. And here we are just looking at this image, just staring at it, just because it's so cool. This is one of the geologists on the mission, and she's just, geologists, they normally walk outside and they walk up mountains and they walk across valleys and river plains and so forth. Now they're doing the same thing on Pluto, just trying to explore what all the geology is on Pluto. Now, that was just one image that we got down from Pluto. We took about 2,000 images of Pluto, but most of them didn't come down on that first day because it actually took about a year to send all these images down. And the spacecraft can only do one thing at a time. And so we weren't having it send down most of its data on that first day. Instead, the spacecraft was just observing Pluto. It was going click, 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 click all day long. It was taking more and more pictures of Pluto. And it wasn't talking to us and it wasn't sending them back. So we were actually, we didn't know whether it was doing okay or not. We'd programmed it. We told it just to take pictures and then one time take a break and tell us if you're doing okay. So we're waiting for what we call the phone home signal, kind of like ET phone home. We're waiting for the phone home signal from our spacecraft to tell it, for it to tell us whether it's doing okay or not. So we're anxiously waiting to hear from it. Here we are, we're all in a conference room, waiting to hear from our spacecraft. Finally, we heard from it. Here's the reaction when we heard from our spacecraft. You can see this guy at the bottom there. He's really excited, and you can see how anxious he was up above. Here's one of the scientists on the mission. She's one of the geologists who studies the heat coming from Pluto. Here's other astronomers who were on the mission waiting for it. What's amazing is it took us 9.5 years there. It's 6 billion kilometers away, and we arrived 1 minute early. So it's really, in some ways, it's really easy to navigate through the solar system because there's no potholes, there's no traffic lights, there's no weather. As long as you point your spacecraft in the right direction, you're going to get. So here's another picture of it. Stretched the colors a little bit, just made them a little bit brighter. And you can see all the different parts of Pluto. You can see where there's all this red dust on the left there, and you can see where there's some of the ice is all purple and yellow. And all this is ice. It's made of, in the room that all you are in right now, you're breathing oxygen, and there's nitrogen in the room, and there's water vapor, and there's some methane, maybe there's some ethane, all these gases that are in the air that we breathe. But if you go out to Pluto, Pluto's 300 degrees below zero. If you go to Pluto, everything in your air turns to ice because it's so cold, and so it would rain down and kind of make a snow on the ground, all the atmosphere in your room. And that's what Pluto's made of. Pluto's made of all the same stuff that the atmosphere here is made of, and all the same rocks that the Earth is made of. But they're so much colder that they don't float out into an atmosphere. Instead, they sit down on the ground and they turn to ice. Here's a zoom in of some of the ice. And we're going across the big glaciers on Pluto. These are glaciers like in the solar system, but they're glaciers which are made of nitrogen ice. And so on Mount Everest, you see glaciers sometimes, and glaciers kind of flow. Well, these glaciers on Pluto are flowing around and moving a little bit across Pluto's surface too. In fact, they're moving a little bit like, what these little shapes look like. If you're making some pudding on the stove, and it kind of turns over and boils over a little bit. The nitrogen on Pluto's surface is moving a lot slower than that, but it's the same basic idea that there's lots of heat inside, and the heat is trying to get out, and that's causing the surface to move around a little bit. So we think of ice as being solid, but just like ice in the glaciers on Mount Everest kind of slowly creeps, this ice on Pluto slowly creeps as well. Here's something else which is really cool. These are mountains on Pluto, and here we have a big ice mountain. It's actually 4 kilometers high. You can see in the middle there, middle top, and you can see how long those shadows are, and that's how we can tell how high this mountain is, by the length of its shadow. But this is a 4 kilometer high mountain. That's half as high as Mount Everest, and this is on the smallest planet in the solar system. What's going on there? That's crazy. Here's more areas where it looks like there's an ocean there, but the ocean is frozen nitrogen. Here's Pluto's moon named Charon, and you can see that's a big crack going through it in the middle there. It has lots of craters on it too, probably more craters than Pluto does, and this big crack. What's going on with that crack? Well, what we think is this here. If you're cooking a loaf of bread, you put it in the oven and it can get really hot, and then when it heats up or when it cools down, it can crack. Well, that's probably the same thing that's happening on Pluto, that it's expanding or contracting because of heat, and that's causing these cracks on its surface on Charon. We have all the other moons of Pluto as well: Styx, Nix, Kerberos, Hydra, plus Charon. We took pictures of all of them. We flew past all of them. We're making, we have all these new features, all these new mountains and plains. We're making maps, and we're naming them not after, we're trying to name them after famous writers and famous literature and famous people and cultures all across the world, from Norway and from Nepal and from China and from Australia and from Mexico. We're trying to incorporate the stories and cultures from all over the world into the names on Pluto. Here's one of the mountains on Pluto, and you can see how bumpy that is, and all the flat stuff in the plains, the icy plains on Pluto. And here's another image, and this is really cool. You can see the edge of Pluto there. And then as we're scrolling down, you can see all these craters here with black in them from something we don't know what. And then all these scratches, these look like kind of like scratches from a cat going across the surface of Pluto. And then the land gets more bumpy, and then you have this land with all these valleys in it. And then suddenly it changes, and it looks like you're at the beach. It looks like you're at the ocean here. This is an ocean of frozen nitrogen. And since we're going out into the ocean, this is on the big heart of Pluto where we're going across now. And then those look like waves in the ocean there. They're actually frozen in. Those are little pits, which are carved by the sun. The sunlight boils away little parts of it. So if you would have asked me or asked other astronomers what Pluto would look like before we got there, if you would have asked us to guess, here's what we would think. We would think that it's like, it's kind of dead. It's kind of old. There's lots of craters there. And all of my predictions were completely wrong because Pluto doesn't look anything like what we thought it would. But that's okay. I don't care whether I'm right or wrong. What's really interesting is learning something. And if you're wrong and you learn something new, that's really more exciting than being right and then you don't learn anything at all. So you want to be wrong as much as you can. So we went past Pluto in 2015. It took us about a year to transmit all the data back. And then we were looking at it, and then we're like, hey, well, what should we do now? So we looked at a map of the solar system, and we're like, well, this is really interesting. Maybe there's something else that we can go past. And so we noticed that we were going through the Kuiper belt, and we thought, maybe we can find something else to go past. And so we used our telescopes, and we're like, there's nothing here, nothing here, nothing here. And finally, we used the Hubble Space Telescope when we found a couple of objects, including one right here. It's in that green box. And we found this object, and we were actually able to steer our spacecraft to go past it. And its name is Arakoth, which is named that's a Native American name from Maryland, which is where the Hubble Space Telescope and our spacecraft are operated from. It means sky in the local Powhatan language in the culture there from that area of Maryland. It's called Arakoth, and it was discovered in 2014, just before we got to Pluto. And it's just, you can see it moving across the sky there, but it's really hard to go past this thing because we don't know anything about it, and it's a long way away, and we don't know its position or its size, and it's so much smaller than Pluto. It's 1 million times smaller than Pluto, and it's 10,000 times fainter than Pluto, and it's 2 billion kilometers further out in the solar system than Pluto. We don't know its size or its position or its brightness or anything like that. And you might think that you could just like take a picture with the Hubble Space Telescope and like that's cool. Okay, so here's a picture of the Hubble Space Telescope, and you can zoom in on it, and you can zoom in on it, and you can zoom in on it some more. But the more you zoom in on it, it just gets like to be a more and more terrible picture, and you can't really see anything here, even with the Hubble telescope. And so there's actually we had to use a trick. We had to actually use a whole lot of small telescopes from the ground to measure the position of this body called Arakoth. And what we needed to do, we needed to know where to fly our spacecraft to, because if we didn't know where the position of this was, we wouldn't know where to steer our spacecraft to, and then we couldn't observe it. So there's a special way where we could measure the position of this body by using small telescopes from the ground. So we had to buy a lot of telescopes and rent a lot of pickup trucks and drive all around the world to observe this thing from the Earth. So here we are in South Africa. We bought 25 of these big telescopes, and we flew them all down to South Africa, and then we took them to Argentina as well. And what we're observing is essentially like a solar eclipse of this body called Arakoth. And you know how if you're in the US a couple of years ago, there was a solar eclipse that went across all of the US. And solar eclipses go across different parts of the world in different times. And they block out the light from the sun for a minute or so. And the same thing was happening with our body. It wasn't going in front of the sun, but it was going in front of a distant star. And so we were watching this star and seeing when its light went away. And it wasn't going to go away for a couple of minutes. It was going to go away just for 3 seconds. So one tiny, tiny faint star that you would never notice in the sky was going to go away for 3 seconds. But if we observed that star, then we could use that to measure the position of our object, and then we would know where to steer our spacecraft to. So here we are. We spent months of planning to go down to South Africa to observe this. Here I am in South Africa as we're observing this. We missed it. We actually were in the wrong place. We had So we did it again. We used a Boeing 747. We used a telescope in Boeing 747, and maybe we saw it from there. Then we went to Argentina, and we saw it there using 22 telescopes. And then I went to Colombia. We used 9 telescopes there, and we almost saw it from there, but it got rainy and cloudy, so we didn't. So in the end, we saw this from enough places, so then we knew what the position was and what the shape was, so that we could steer our spacecraft to go visit it. So, and we knew that we would get to Arrokoth on January 1st, 2019. So just about a year ago. So here we are. Here's a picture of it as we're getting closer to it, and kind of looks like this. It's that blob in the center there. Here's our control center. This is our in Maryland as we're assembling to observe this body. All of our team is back, and we're getting closer and closer every day. Now, we were gonna observe this on January 1st, 2019. What also happens on January 1st? Well, that's New Year's Day. Were we celebrating New Year's Day in this photo? Almost. This is 12:33 a.m. though. So all of you who were up, you might have celebrated the New Year's Eve at midnight. We celebrated New Year's Eve at 12:33 a.m. because that's when we finally flew past this Kuiper belt object named Arrokoth. So here are kids of all the scientists on the mission. That's my daughter there in the orange space costume, and we're celebrating that it's 12:33 a.m. and our spacecraft is going past Arrokoth. Here's the leader of our mission and the mission engineer, Alice, on the right there, high-fiving because we've successfully went past Pluto, or went past Arrokoth. And here's the first picture as it's coming down, and it's kind of funny. It looks like a snowman. Our shape. Here's what we predicted it to look like from our telescope observations and what it actually turned out to look like. The shape looks right on. It really looked like the snowman that we predicted it to. So this is a really hard observation. We were really excited to see this. People get really emotional about this. And here's what it looked like. So you can look at that picture on the right, the brown one there, because our pictures kept getting better and better as we were downloading better and better images. And this body here, it looks like kind of a brown snowman. And this is really small and really old. So Pluto is about 1,000 kilometers across. So it's about the size of a country, about the size of India, a little smaller than the US. But this body here is about the size of a city. It's only about 15 kilometers across. And we call this a planetesimal. So this is one of the raw ingredients that goes into making the planets. So it's not a planet itself. It's not a comet. It's not an asteroid. But this is the most ancient, oldest, most simple thing that we've ever come across in the solar system. And so if you would have had 1 million of these, you could put 1 million of these together, and you could make something like Pluto or make the Earth. But basically, this has been sitting out in the outer edge of the solar system for 4.5 billion years, untouched and undisturbed. And you can see it hasn't been hit by very much because it doesn't have very many craters on it. A couple craters you can see, but it's mostly been slow, mostly just been very calm and quiet and undisturbed. So this is like a time machine. If you visit this body, it's like going back in time 4.5 billion years to tell us what the solar system was like then. And if we can learn how our solar system formed 4.5 billion years ago, maybe we can learn how other solar systems formed, and we can find out if the things that made life in our solar system might go into making life in other solar systems as well. It kind of looks lumpy, just like a loaf of bread. It looks like it's made up of a bunch of different pieces that stuck together. It's probably a cloud of pieces. And then if we stick enough of these bodies together, maybe we'll make up a Pluto like these and make up the other planets. This is a great picture, but we don't really know a lot yet about the outer solar system because there's probably thousands and thousands of these out in the outer solar system that we haven't explored yet. We don't know whether other ones look like this. We don't know why it has 2 chunks rather than 3, or rather than 10, or rather than 1. We haven't downloaded all of the data yet because it's a long way away and it takes a lot of time for all of our data to come down. And so our spacecraft keeps flying. It's going to keep on going. It didn't land on Pluto. It didn't land on Arrokoth. Give it another 10 years and it's going to leave the Kuiper belt. We're looking for something else to fly past. We don't know if we'll find it right or not. And eventually, our spacecraft's going to leave the solar system. Woo! So it'll leave the orbit beyond the gravity of the Earth. But it's going to take us 50,000 years to get there. So I don't know if any of you will be alive in 50,000 years. I do not think I will be. but our spacecraft will still be going in 50,000 years. In another 500,000 years, 500,000 years, it's going to fly by another distant star. Now, the spacecraft isn't going to be operating until then. It's going to fly there, but the batteries and the fuel are probably going to run out in another 10 or 15 years. So this is our team here. Thanks for coming along with me on this mission. We're really excited to do this mission and continue flying to explore the outer solar system. There's the website, pluto.jhuapl.edu. That stands for the Johns Hopkins University Applied Physics Lab, and that's the center that NASA asked to build the spacecraft and where they operated it. And you can also find more about the mission if you just go to Google and enter New Horizons or New Horizons spacecraft. Wikipedia has a really good page about the New Horizons spacecraft. There's lots of pictures, lots of science out there to learn about it. And thank you for coming along with me on this mission. I'm going to stop sharing the screen now and go back to and be able to take a couple of questions. So if you have some questions, you can enter them into the chat window. So let's see, one question quickly. Are we going to be able to watch this talk again? Yes, we will. I will record it and post it on the same link that you saw it originally. Here's a question: if there had been dust near Pluto, what would have we done to avoid breaking the spacecraft? So what we had a backup plan, and our backup plan was that instead of going, we flew about 2,000 miles above the surface of Pluto. And instead of flying 2,000 miles above the surface of Pluto, we would have flown someplace else instead. We would have flown maybe 10,000 miles from Pluto, where it would have been a safer region. Now, we wouldn't have gotten as much science, we wouldn't have gotten as close to the surface, and our pictures wouldn't have been nearly as good, but we would have been able to see still some great stuff on the surface of Pluto, and we would have done it safely. Someone has a question. Kai wonders what the gold material is in the spacecraft, and the gold material is actually a blanket. It's a blankie, just like we all have. This is made of gold, and that keeps the spacecraft. It actually keeps the spacecraft cool when it's near the sun, like when it launched, and it keeps it warm when it's out in the outer region of the solar system. Gold is actually pretty good because it's very reflective, and so it keeps the temperature of the spacecraft correct. Here's another question: is Arrokoth the same as Ultima Thule? Yes, they are the same thing. This Kuiper Belt object has actually had a lot of different names. First, we called it MU69. Then we called it PT3, which meant potential target 3 when we weren't sure whether we could fly past it or not. Then we called it Ultima Thule, and finally now we have our permanent name. All those were temporary names, but this is its permanent name, which is called Arrokoth. So you can always call it Arrokoth from now on. Okay, here's another question. Why do some people consider Pluto not a planet? Oh, that's a great question. In fact, you know what? I'm going to put up another slide here, a couple of slides. So I'm going to share my screen again and just talk about whether Pluto is a planet or not. So question, what is a planet? The planet is a Greek word. The word planet actually means wandering star. And the Greeks came up with this word 2,000 years ago because they thought that everything up there, Jupiter and Saturn and the moon and the sun, they thought they were all wandering and they were all stars. Well, if we know anything, we know they're not wandering and they're not stars except for the sun. All the planets follow very predictable orbits, and so to call them wandering stars is just not right. But no fault to the Greeks; they didn't know back then. And through time, the word planet has sometimes people call moons planets, sometimes they call the word stars planets, sometimes people have called asteroids planets, sometimes people have called the sun a planet. And now we kind of have a better understanding of what planets are. Some people call Pluto a planet because it orbits the sun, and Pluto's big enough that its gravity makes it into a big round ball. It has all these moons going around it. It has an atmosphere, and of course, we've always called it a planet. So for those reasons, maybe you would call Pluto a planet. But also, Pluto's a little different than the other planets. It's definitely smaller. It has kind of a weird orbit where it's shaped like an egg and it's tilted. And Pluto's a lot more like all the other Kuiper Belt objects. And we don't call those planets because, we just have, the small number, 8 or 9 planets in our solar system and not 2009. What would we call those? And if it was discovered today, maybe you wouldn't call it a planet because it's more like the Kuiper Belt objects and the icy planets. So there's reasons for you to say yes, and there's reasons to say no. There's a group called the IAU, the International Astronomical Union. They came up with a definition of like, oh, all these things should be a planet. And if you look at their definition, it's a really confusing definition, and it doesn't make a lot of sense, because a lot of the things in their definition like would say that Jupiter isn't a planet, or Saturn isn't a planet, or Earth isn't a planet. So scientists don't really know, and but scientists make up it's our job to come up with a definition of what a planet is and what planets aren't. And I think a lot of what it boils down to is just size. How big is something? Like, we call something a planet if it's really big. Like if it's 10,000 kilometers across, we call that a planet, yay. But if it's really tiny, does anyone call a dust particle? Let's say you're holding a little pebble that's a centimeter across. If you're holding that in your hand, is that a planet? Most people would say, no, that's not a planet. But something that's really big is a planet. And Pluto's kind of funny because it's right in the middle there. It's about 1,000 kilometers across in diameter, so in radius. So do we call that a planet? Yes or no? And so it just boils down to size. Like, where do you draw the line? Where's the cutoff in size? It's kind of like, what's a mountain and what's a hill, and what's a butte and what's a peak? If something is just if it's 100 feet high, is it a mountain? Or what if it's 10,000 feet high? Is it a mountain? So where do you draw that line? So there was actually a group that voted in 2006. They voted no, Pluto is not a planet. But their vote wasn't really very useful, because a lot of people still call it a planet. A lot of astronomers still call it a planet, and you can too if you want to. Okay, here's another question. How far away is the edge of our solar system? The edge of our solar system is, we've only gone about 1% of the way to the edge of our solar system. So the closest star is Alpha Centauri to us, or Proxima Centauri actually, which is about 4 light years away. And so about the edge of our solar system is about halfway to Proxima Centauri. So it's about 2 light years away is where the edge of our solar system stops, and their solar system begins. And so you need to go that distance. And we have hundreds of thousands of more years until we actually get to the edge of our solar system. We don't know the stuff that's in our outer solar system. There's probably no big planets out there. But if there were, they would be hard to detect in our outer edge, because they're so far away, which means they're far away from the sun. It means they're dark and they're moving slow. And there could be big planets out there that we just don't know about yet. Here's another question. Do we retrieve the tanks? Yes, we do retrieve a lot of the hardware that came off the spacecraft and fell into the ocean, because we don't want to pollute. Can we refuel it? No, we actually do not reuse it. The SpaceX is a company that builds reusable rockets, and ours was not reusable. Building reusable rockets like SpaceX does really makes a lot of sense, because a lot of money goes into building this rocket one time, and it would be great if we could reuse it. And in the future, we'll be able to reuse things a lot more than we can now. What is Pluto made of? Basically, Pluto is made of ice and rock. The rocks are the same sorts of rocks that are on the Earth's surface. They're made of elements like silicon and like iron and like magnesium. And these are the same rocks that are on Earth. So you could pick up a rock and it would just look like a rock. It wouldn't like be glowy and spacey or anything like that. It would just look like a rock. And then it's also made of a lot of ice, because all of the atmosphere and the water and so forth on Earth would just turn to ice when you put it at the temperature of Pluto, because Pluto is so far away from the sun. Oh, here's another question. Okay, if someone found aliens, what would they look like? You tell me. I don't know. We've never found any aliens. That's anybody's guess. I'm going to leave that all to all of you to find out what aliens would look like. NASA's been looking for aliens in the solar system, or for life in the solar system, for a long time. We have a lot of missions that are designed to look for life in the solar system, especially at missions at Mars. So we actually have a rover which is going to launch to Mars hopefully this summer. It's called the Perseverance rover, and its job is to cruise around the surface of Mars and find some interesting rocks and pick them up and put them in a box so then we can bring them back to Earth and study them. Now, we don't think that maybe there's probably not, kangaroos and kiwi birds walking around on the surface of Mars right now, because Mars is pretty dry and pretty dead from what we've seen. We've sent a lot of spacecraft to the surface, and we've never seen anything walking around or anything like that on Mars. But we think there might be bacteria below the surface, or there might be fossilized bacteria below the surface. Because although Mars is really dry now, we know that Mars actually used to be really wet. It used to have oceans on it, just like the Earth's oceans. Okay, here's a question. Well, when will New Horizons be slow enough to land? The answer is never. New Horizons has enough velocity that it never actually loses its velocity. It's gonna, even in millions of years, it's going to, as long as it doesn't crash into a star, it's gonna have enough speed to just keep on going and escape the gravity of any stars that it goes past. Okay, here's a question. Why not just send a spacecraft to refuel New Horizons? Well, that's a great idea, except it's to send a spacecraft out to refuel New Horizons, you'd have to get that spacecraft out there, and you'd have to send all that fuel out there, and it would take just as much fuel to send that fuel out there, and it's really, really hard. It would just take, and then it would never catch up with New Horizons, because if you put enough fuel on it to be useful, it'd be moving slower than New Horizons is, and so it would never make it out there. So maybe we can fix this by building in the future. We can build smaller and smaller spacecraft so that the cameras can be smaller and the batteries can be smaller. And if we can build a smaller and smaller spacecraft, it doesn't take as much fuel to slow it down. So perhaps in the future, we might be able to send something which actually could slow down and land on Pluto, or maybe easier, it could orbit Pluto. We've never done that yet, but there's actually a group at NASA right now which is studying a Pluto orbiter. Okay, here's another photo. It says, you said that your photo of Ultima Thule was the highest resolution ever, but I've seen better photos. Are those fake or CGI? So if you have seen higher resolution photos of Arakoth, or Ultima Thule, but mostly we call it Arakoth now, that's probably like an artist's rendition. We actually made up some images beforehand, before we went past, of what we guessed that it would look like. And we always said, like, oh, this is just an artist's impression of what it might look like. And you can sometimes tell that it's an artist's impression because it has the spacecraft. It would be like a picture that has the spacecraft in it and Ultima Thule as we're flying past it. And so any pictures of the spacecraft itself, like the space, we can't take a picture of New Horizons itself as we're flying past. So if you see a picture that has New Horizons and Ultima Thule in it at the same time, it's probably one that just an artist has made. Here's another picture. Oh, another question. Will anyone ever go to Pluto? Oh man, I hope not. I mean, it's really cold. It's so unbelievably cold out at Pluto that it's just not the best place to live at all. Like even if you go to the coldest places on Earth, like go out to Mount Everest, where it's cold and there's much less oxygen to breathe, and it's extraordinarily difficult to live up there. Living on Pluto would be so much worse. Now, maybe you could just go to Pluto to explore, but I think it makes so much more sense for robots to go to Pluto than for people to go to Pluto. We can send, it's so much cheaper, it's so much faster, and you can do so much more science by sending robots out to the through the solar system than sending people out there. There's some places that people are great for, but going to a world like Pluto, probably not. Okay, here's another question. What if you turn it off for 50,000 years and then turn it back on? That would be great. But it actually turns out that the battery will wear out by itself after 50,000 years. The battery is made of plutonium, and the battery runs out after 88 years, and that's whether we're using it or not. The battery is just a hunk of plutonium. It's radioactive, and it decays slowly. And so even if we turn it off, then we're out of electricity in just that number of years. Oh, hey, notes from people who've lived in Mumbai and in Mexico, and note from someone who was a finalist in the Naming the Rover contest. That was really cool. This is the Perseverance rover. Up until the name up until now has just been called the Mars 2020 rover, which is a really unexciting name. But there was a large contest that where anybody in school in the U.S. could submit a name, and then people around the world could vote on those names. And Perseverance was the winner of that contest, and that was just announced maybe about 3 weeks ago. And it was a student in Virginia who came up with that name, and so it's a great name. We're really excited to have the rover hopefully launching this July. Okay, here's another question. What would happen? Okay, we got that one. Are there any signs that Pluto had or has water? Yes, Pluto has lots of water, but it's all frozen. And in fact, the water which is frozen, it basically just acts like a rock. Frozen water ice at 300 degrees below zero is so hard, you wouldn't be able to break it open. You wouldn't be able to chew on it. It's just like eating a rock. It's so hard. But we actually think that the mountains on Pluto are made of water ice. So they're just like a glacier here, but they're colder, colder, colder. Oh, here's a question. How did I get an asteroid named after me? Yes, there is an asteroid named after me. There's an asteroid named Henry Throop. It is a asteroid which was discovered by Mark Buoy. He's one of the scientists on the mission, and he's actually the one who discovered the body called Arrokoth. And he was very gracious to name a lot of the asteroids that he named after that he had discovered after many other members of the team. Let me take two more questions, and then we'll wrap up here. Could we heat up Pluto and melt the ice? Yeah, but that would be really rude to Pluto. We actually want to protect the solar system. In theory, if you had a lot of energy, you could heat up Pluto and melt it, but then we would destroy a lot of history of Pluto. NASA's really careful about protecting the solar system, because one of the things we don't want to do is, for instance, take bacteria or bugs or creatures or anything like that from the Earth and pollute them onto another planet. Like if we have a spacecraft that's going to Mars, we need to sterilize that spacecraft by putting it in an oven and wiping it down with Lysol and so forth, being very careful when we're building it, so that we don't bring life onto Mars or bring life to the Moon or bring life to Enceladus or Europa or anything else like that. So one last question: why use a battery instead of solar panels or something else that can recharge? Yes, great question. We actually are able to use solar cells through a lot of the solar system, but just like Pluto is really cold, and that's because it's far away from the sun, there's also not much solar energy for solar cells out in the outer solar system. And so Pluto is about 40 times further away from the sun than we are. And the way you can calculate how much energy gets out there, it actually, you multiply 40 times 40, and it's about 1,600. So it's more than 1,000 times less energy you can get from solar cells at Pluto. So it's you'd need solar cells that are 1,000 times bigger on Pluto to power your spacecraft than at Earth. And so that's just too big of a solar cell. You couldn't fit in the rocket. It would be too heavy. And that's why we're not using solar cells, because it's just too far away. So this is awesome. Thank you so much for everybody for coming here. Thanks so much for all your questions. If you have more questions, you can follow up with them on Facebook, or you can send me email. You can find my email address pretty easily online. And so be well. Thank you, everybody. Bye-bye.